Hi, everyone. As you said, I'm Paul Ganssle. I work at Bloomberg. I'm a software engineer there. I also am a pretty frequent contributor to open source. So today I'm going to be talking to you about contributing to open source. Usually when I interact with people and they hear that I do a lot of open source, I maintain libraries like dateutil and setup tools, and I've contributed to a number of projects. I often hear, oh, I'd like to contribute to open source more, or I'd like to contribute at all, but it's just too hard. I don't have the patience to deal with people who are always asking for all these changes, or they it feels like screaming into the void. I'm just opening issues and pull requests and no one ever responds to them. I'm not going to pretend like that doesn't happen. Probably part of the reason why I don't find contributing to open source terribly difficult is because I have a less strenuous definition of what is too difficult to actually accomplish. But I have found that there are a couple things where if you sort of know the right ways to do things, if you understand what everyone's mindset is, and also if you just try and keep open good lines of communication, you can make things a little easier at least. So why do people contribute to open source? One of the reasons is that you have some problem and you need to solve it, and you don't want to maintain a fork of the upstream library, or maybe it's like the guy shoveling his snow here, the snow from his path here, right? When he fixes his problem, which is I can't get to my car, he can fix it for everybody by shoveling the sidewalk instead of just picking up the snow and then putting it behind him as he goes, so that no one else can make use of that. Another reason to contribute to open source is for the community, right? Maybe you like interacting with open source maintainers, or maybe you like contributing to some greater thing, or maybe you feel like they've done a lot for you. They've provided libraries that you use, and you want to give back in some sense. That's how I initially got involved. And also, it's it feels kind of cool to be like, hey, I built this thing which is used by Nobel Prize winners or whatever, or any of these kind of hugely used projects. It's kind of nice to know that you've done even some small part of it. But I should note that these types of contribution are two very different modes, right? The first one is very goal-oriented. It says, I have some kind of change that I want to see in this project. The second one says, I would like to help you, so what are the changes that you would like to see in the project? Now, I think that open source needs both of these types of contributions. So I'm not going to say one is better than the other, but you should note that they have very different challenges. The first one has a challenge which is, I need to convince you to make this change. The second one is, I need to find the things that need to be changed and the things that will be useful contributions. So just keep that in mind as you're making contributions, that those are the two challenges. So what are the types of contributions you can make? The first one, the big exciting one, is features. If you add a feature to something, it's very visible. It increases the abilities of the project. You're like, oh, I added this. I made it so Matplotlib has radial plots now or something, right? But features are one of the hardest things to get merged into an open source project. And the reason is that they're very complicated. They use a lot of they take a lot of time. There's a lot of communication that has to go on. And generally speaking, you end up with some situation like this kind of feature where someone sort of half constructs it, they want to put in a door and they only get through the stairs, or maybe it's something where there's a miscommunication. It's actually the stairs are supposed to go in front of the door in the front of the house, and you put it on the side of the house. So, these kinds of things, there's a lot of avenues where you can just go, just take a wrong turn, and then your thing never gets merged, and it just blocks. Easier to get in is bug fixes. Of course, it's a sort of definition problem, like what is a bug fix and what's a feature, what breaks backwards compatibility and what doesn't. But if something in the library was obviously intended to work a different way, and you can fix it without breaking backwards compatibility, that contribution will likely get accepted if it's well formed. And so that's probably easier to start with for your first contribution. But again, you're going to need communication to make it clear that you understand what the maintainers think the bug is, and that and that you're listening when the maintainers are trying to figure out whether you're all on the same page. And then there's documentation fixes. Documentation fixes are basically like you just merge them before you even read them. That's not actually true, but a lot of the concerns with bug fixes and features and stuff are just not there with documentation fixes, in the sense that there's no API compatibility issues. If something goes wrong, you just fix it in the next merge. It's not a problem. And there's also no chance that changing the documentation is going to break someone's existing code in prod, right? Like you're going to hear it if you make some bug fix that breaks a bunch of stuff in prod because people were relying on some behavior of your library that you considered a bug. If it's documentation, you'll hear about it eventually. And the other reason why documentation fixes are pretty easy to get merged is because documentation is pretty labor intensive, and so it tends to decay faster than things where you can have automated tests for it, which is all just to say that documentation is easy to get merged, not because it's easy to do, but because it's hard to do. And another kind of contribution that is often overlooked when thinking about contributing to open source is issues. So generally, when you're using some application or some library or whatever, and it has some issue, do you stop everything and find the correct repository and then write a detailed error message that you send to the maintainers? No, obviously you don't do that. You just work around it, or just be like, oh, how annoying. And then you continue about with your day. But that's essentially the only way that maintainers get feedback about how their libraries or projects are breaking in the real world. And so anytime you see an issue, you probably have 100 or 1,000 users who have the same issue, but just kind of ignored it. But an important part of writing issues is writing good issues, because a lot of times you can make an issue and you say, here's this problem, and then you walk away and nothing ever happens with it. And part of the reason why that happens is because you need to make sure that essentially issues that don't have certain elements are a lot harder to reproduce, they're a lot harder to understand, and as a result, they're a lot harder to take action on. So here's an exemplary issue that I took from the formatter Black. This person, Ned, made this issue. It has to do with type annotation comments. And you note they start with the list of their versions, their operating system, the version of Black they're using. They checked if it worked on master, and the version of Python that they're using. Right? All of that is so that when the maintainer goes through and tries to replicate your issue, and if they can't maintain it, they don't have to come back and ask you like, okay, what is your version of Python? And then they try it again, right? You put all that up front so that they can replicate your environment as a starting point. They also put their motivation. One thing that maintainers are going to be looking for is this in scope? And if you're not telling them about your use case, they're probably just going to say, well, I can't imagine a time that I would need this, so maybe this is just out of scope. So if you give a little background about here's why I need this, they will either tell you, this is kind of out of scope, here's the right thing to use, or they'll say, I never thought of that, we'll do it, we should merge that. Then it's followed up with a minimal reproducing example, right? So this starts with some code, and then the outcome of that code, in case it doesn't reproduce on my machine, and I'm seeing something different. And then also the desired outcome. So what they've done is they said, here's some code, it does this, it should do this. These three things allow you to pretty easily understand what the bug is. And you'll also notice that this is called a minimal reproducing issue. So this is not a link to some repository, and then the guy says, oh, run this on my code, and then look at line 753, and you'll see that there's a problem in the third argument, right? It's def f and three parameters named A, B, and C. Like, this is the absolute bare minimum. It's 4 lines or 5 lines of Python that you can save to a .py, run black on it, and it gives you the thing. Now, making these minimally reproducing issues is hard. I suggest reading up about them because they are a skill that's worth its weight in gold, though that doesn't really make sense because ideas don't have weight. So that was a bad metaphor. But I recommend reading Matt Rockland's blog post on this, craft minimal bug reports. And also, the elements of a good issue are very similar to the elements of a good Stack Overflow question. So reading the Stack Overflow help on how to create a minimal, complete, verifiable example is also very useful for this. But that sounds like a lot of work. So I suggest you don't do that work if you don't need to. So always start by searching for the existing issues and pull requests. Because you might find that someone has raised the exact same issue, and maybe they only got halfway through the process, and you can find a more minimal reproducing issue. Or you can, sort of move the ball down the field like another 10 meters. You'll note that we all fall prey to this. So this is an example of an issue that I raised on dateutil, which had been raised quite a long time ago. And the maintainer was like, yeah, this is a real issue and we should fix it. And that maintainer was also me 3 years ago. So I should have taken my own advice. So now you've got your issue done and you have, and you're ready to make a pull request. Like, how do you get your pull request accepted? To start, we have to take a little detour into like maintainer psychology, because when the maintainer is the one that they're going to have to push the merge button. And the first thing to note is that the maintainer is probably assuming that you're going to go away. You're going to give this contribution, and it's going to be welcomed, and we're going to say thank you. But then we're going to have to deal with that for the next several years. So we're going to be looking at the pull request from a holistic point of view. Like, how does this fit with the rest of the library? Does this have backwards compatibility issues? Is this something that's going to be harder to fix if I'm not totally right about it? And also, do I understand it? Do I understand that this is the right solution? Another critical factor in maintainer psychology is that maintainers generally are time-strapped. They're not usually people whose full-time job is doing this. They just do it kind of on weekends or lunch breaks or after work or something. So they're going to be looking for things that they can do in short bites, 30 minutes at a time. They can understand it quickly, and then they can take action on it, and then put it on a to-do list. And the longer it goes, the more likely it is to go on the long list, and they're never going to look at it. So what you want to do when you're crafting your pull request is to make sure that it's something that can be easily verified, which means that it has tests usually. Sometimes it feels like when you're a maintainer, your whole job is asking people for tests. You say, oh, can we add some tests? This line is not covered. Oh, we need to cover this other feature. It's not just me, Jeff over there, also asking for tests. And in Matplotlib, they're also asking for tests. I had a joke. This was supposed to go over the edge of the slide, but this screen has more screen resolution. So let's just pretend I have 6 more of these issues. But yeah, tests are critical. If it comes in with tests, I'm immediately going to look at it much more favorably, because I can easily say, if I merge this and then I do something that breaks it, that breaks the thing that you just fixed, I will know about it. You also need to provide context. So if I were to give you this thing and say hey, if you're trying to review a contribution, you kind of need to know what it's for, right? So I give you this thing, and I say hey, how good is this at whatever it does, right? What? I don't know. Yeah, I found this by searching for contraption, right? But now, if I tell you what this does is it takes the energy from a falling weight and uses it to launch ping pong balls. Immediately, several elements fall into place. There's a weight right there. That's probably used to launch the ping pong balls. What's this rod for? Oh, well, it's the same diameter as the thing with the weight. This is probably something with air in it. Here's a tube. I understand the entire machine immediately from the context, except for this part, which is some kind of yellow square thing. And that is the part of the contribution that you want to review. You're going to say, what's this yellow square thing for? And then they're going to say, oh, it's for measuring the angle or whatever, right? And then you say, great, merged. You also want to do things in manageable chunks, 1 change at a time. again, maintainers are not going to have like 3 hours to dig into your problem. So if you have some pull request that's like 700 lines and it changes 5 different features, that is great. If you had done it in 5 different pull requests, like if you like totally overhaul my library and fix all the bugs, that's awesome. If you do it in 1 pull request, that's a ton of work all at one time just to press the merge button. So you're going to want to do things in manageable bites. And you also want to consider the support burden. Things that change the public API, add to the public API. Those are things that you have to support in an ongoing way. As soon as it gets merged, if you decide that you don't want it anymore, you have to go through a deprecation cycle. So you're coming along with your feature and you're saying, hey, here's this free feature, isn't it great? You know, and you're thinking that free as in beer, but the maintainer's thinking that it's free as in puppy, right? And you know, funny story, I was searching on CC search for the Creative Commons licensed images, and I searched for puppy, and I was like, oh, look at that cute little guy. You know what the name of this is? This is redwolf.jpg. So this guy's not going to grow up to be like a fun dog. This is a wolf. Okay, so we're through with the social aspects of contributing to open source. Hopefully this is not going to just bore everybody, but I find a surprising number of people, well, not surprising because Git is this crazy, weird, and complicated thing that most people don't understand, but a large number of people don't really understand what's going on when they're making a pull request, so I thought I would just go through and give you some abstractions that I have found very useful. So with Git, you have some repository. Say this is the canonical repository. You want to make a copy of it that's called cloning it, so you'll clone a local copy. You always work in a branch. You don't work on the master branch because it's way harder to sync things when you are working directly in your master branch. So you make a branch. These add your commits. And then you'll either push those commits up or the other person will pull them to their branch. And then when they're ready, they'll take those changes and they merge it, and that creates this little merge commit. But GitHub is slightly different than Git in the sense that it has more permissioning issues and it has a slightly different workflow, but it's still based on that same concept. And I talk about GitHub not because we're at Microsoft, but because some huge number of open source projects use it. But the concepts are similar for GitLab and Bitbucket. So on GitHub, you have some canonical repository. And because you don't have permissions to push directly to that repository, you're going to need to make a fork. And what the fork does is it makes a copy of that on GitHub server that you have permissions on. Then you're going to take that and you're going to clone your fork to your local branch. And you're also going to want to connect it to the original branch by adding it as a remote. So traditionally, your fork is called origin, and the canonical repository is called upstream. And these are all linked together. These two are, origin and upstream are both on GitHub server. Local is on your computer. So local is the one where you can make changes. So you make your branch. You should name it something reasonable, like fixed race condition if you're fixing a race condition. Then you push it to your origin, because that's where you have the ability to make changes. And then from there, you make a pull request to upstream, which is saying, upstream, please pull these changes in and merge them. Upstream will merge them, and then you will pull from upstream, not from your origin, to get these new changes in. And then you can delete your branch and continue working that way. So here's what it looks like. On GitHub, you have you press the fork button. It creates something that's identical, except that it's in your namespace instead of the org's. You clone the repository in your terminal using this little link they give you. You make your commits. You make a branch, and you push it to the origin. And these slides are all online. If you go on my website, Ganssle.io, you can find the links to it. So you don't have to, I know I'm going through this pretty fast. So once you've pushed it to the origin, you can create the pull request. Generally, when you go to the website, it'll helpfully be like, hey, I know you probably want to do this, and that'll pop up. It doesn't always pop up. It only pops up in like the first 10 minutes or hour or something. So if it's been a while and you don't see that, you just navigate to your fork. You change the branch to be the one that you want to, and then you press this button that says pull request. That will open up this dialog, and then you just fill it out. You give it a descriptive. You give it a descriptive title. You give it a description. I've filled in the description that says, this is a pull request to add these slides to this repository. So this is actually, these screenshots are from the pull request that I used to add these, to make these slides. So this is probably not like the most clarity if it wasn't for me, because the maintainer would be like, wait, what? Once that's done, you're going to see this pop up at the end of your thing. This is continuous integration. So generally, open source projects, because again, maintainers are strapped for time, will set up continuous integration, which is something that will listen for changes, or listen for pull requests. It'll pull in those changes, it'll merge them, and then it'll run all your tests. You set it up to run all the tests on different platforms and all that kind of stuff. So you'll see these little hooks. This means it's waiting. When it's finished, you'll either get a check mark that says, hey, all the tests passed, or you'll get like a little X that says like, hey, something went wrong here. So now I know something went wrong. Note that no maintainer has told me anything about what went wrong. It immediately tells me just from me coming back and looking. And then I can dig in. I go on Travis here, and I see that this pull request failed on Python 3.3. I click on the Python 3.3, and I see it gives me a whole log. I find the error message. It's helpfully in red. I find out that this is something about, in Python 3.3, one of my dependencies stopped supporting Python 3.3, so now it's failing. So then I make the changes. I pin that version to 3.3. Everything is green again. I go back into my pull request. Everything is green, and now the maintainer is free to merge. So now I'm going to go through just quickly one of these, an interaction that I thought was pretty good in open source. And please forgive me, GitHub designers and the people involved in this. I just like modified the DOM of this in the inspector so that it would look nicer on slides. So like I changed some of the font sizes and things like that. So this person, they wanted to make a change. They said, oh, here's the error that I'm happening. They gave their motivation, all that stuff. And you'll notice they had 3 commits. One of them is add failing test. So they added tests, good. They fixed the test, and then they fixed the example in the documentation. Great, those are all the elements that we want to see. And the maintainer came in and he said, hey, I would love to merge this at last minute for this change I'm about to release, but could you please add a changelog entry? This is the first place where this could have gone wrong, right? If you didn't come back to look for this, you would not know that they're waiting on you to add a changelog entry. And you said, last minute, right? I would like to merge this at the last minute. So that's kind of time sensitive. If you're paying attention, like if you're watching your notifications, you'll get these sort of timely notifications. So then they said, that's awesome. And they added a changelog entry just by pushing more stuff to their branch. And then they said, oh, also, like, see how this is like a red X? So something is failing. What's failing? And they mentioned it's something to do with the coverage, right? So then the maintainer says, oh, here, maybe try doing this. You use this monkey patch to get it. And if that doesn't work, just be like, you know what, forget it. We don't have to cover this line. It's fine. And then they made the change. They're like, oh, that's great. And they also said, today I learned about PyTest monkey patch. So by having this interaction, not only is this good for the project, it's good for this person because they learned something about Python that they wouldn't have otherwise known. So then it was done, but Travis was still failing. So what they did was they pushed another thing that says make Flake8 happy. So evidently this was some linting error. But you'll notice the maintainer did not say, hey, can you fix this thing that is making Flake8 unhappy? Because they just looked at the continuous integration, saw what was failing, and then fixed it. And then, great, it got merged. It's kind of funny. The good issue on the other one was issue number 282 in black. This is pull request number 282 in adders. So I don't know, there's something about like 282 that makes things good. All right. So hopefully I've convinced you that you should contribute to open source, and I've given you some tools to go out and do it. So what's the next step? What's your action item, right? So let's assume that you want to do the community mode, right? You want to say, I'm going to give back. You want to pick a project. So I would say pick something that interests you, and then look at it and check for indications of activities. You're probably not going to have it's not impossible that inactive projects will merge your stuff and make new releases, but it's probably not great for the first time to try and sort of fight against that because the probability of getting stuff merged in a largely inactive project is much lower. And you want to check if the project has tests. It's a total pain to make changes in projects that don't have tests, because not only does the maintainer not have feedback, I mean, they're probably used to that, but you don't have feedback as you're making changes that you didn't break anything else. And then when you're like, all right, I want to contribute to this, read the contributing.md. That's usually in the root directory of the repository. But if it's not, sometimes it's in like .github. But if you click on pull requests on GitHub, they're like super helpful about this. They're like, hey, there's these contributing guidelines. Like, why don't you, if you click on this button, it'll bring you to NumPy's contributing.md. So now you've found a project, you read their contributing.md, now you want to find an issue. The best way to start is to click on something, is to look for a label that's like good first issue, or one that's like help wanted. A lot of times what happens is that you have these issues that got raised, and the reason that they haven't been fixed is they're like, it's just not clear how to fix them, or they're blocked on some other project, or they're blocked on some other thing that's happening. So a lot of maintainers, especially ones who are welcoming to new contributors, will go through and they'll label all the issues that are likely to be interesting, that are likely to be easy to fix, from a new contributor. We're just going to ignore the phone thing. And then yeah, so I'm just going to keep going here. If you found an issue maybe that you do want to fix, maybe it's an issue that you want to fix because like it's actually affecting you, you should read the history of it and try and gauge what needs to be done. And it doesn't hurt to sort of ask in the issue like, hey, I would like to fix this. Is there anything I should know? Is it a problem? And you'll notice that in this issue, which has a lot of comments, which can be a bad sign if it's a pretty old issue, it probably means that there was a lot of attention paid to it and still no one was able to fix it. They said, is there anything I can do? And the maintainer was like, yeah, we did all the easy stuff, and now it's like hard, and we don't know how to fix the rest of it, so we left it open. But hey, click on the good first issue. That's great. And another thing I would mention is you should stick around. So, there's a lot of overhead, fixed costs that goes into making a contribution. You have to figure out how their tests work. You have to clone the repo, fork the repo, understand how the project works enough to fix this one bug. So fixing one bug is like maybe pretty hard, right? Or moderately hard, right? Fixing 2 bugs is probably much easier than fixing, fixing 2 bugs in the same repo is probably much easier than fixing 1 bug on 2 different repos. So this happened with me. So this is probably the second open source pull request I ever made. It was on dateutil. I fixed some issue with checking against none in a constructor. And then like the next day I was like, oh, actually, I fixed my issue, but then I found a whole other bunch of other places where no one was complaining about it, but we were still doing it. So I'll fix a bunch of those too. And then the maintainer was like, oh, great, yeah, I'm gonna merge that. And I was like, you know what, when I was in there, like I realized, like now I understand how this all works. I'll just go fix this other issue, this issue number 4. So then, now it's been 4 years, and the number of pull requests I've had merged into that is 171. And you can see, that was in December of 2014. Even in March of 2015, I was changing things all over the module. I was making releases, all kinds of stuff like that. So if you stick around, there's probably stuff for you to do. All right, so that's the talk. I'm going to plug a couple things. At 11:30, which is in 9 minutes, over on the far side of the building in Belasco, I'll be participating in this panel, my first open source contribution. So after we're done here, just head on over there. It should be interesting. Next weekend, Bloomberg is hosting a Python Packaging Authority packaging sprint. We're going to be working on all kinds of PyPA stuff, like setup tools, virtualenv, talks. We're going to have mentors and stuff. I think at least on the Saturday, the event is sold out, but you should add yourself to the wait list. And maybe there's still tickets for Sunday. And then finally, I want to thank Bloomberg for give me the time to like make this presentation, come to the conference, and also all the support they've given me in doing open source outreach and things like that, and also just in general, their support for open source has been great. So if you want to come work at Bloomberg, it's pretty good. All right, that's my talk.
Any questions?
Thanks for your talk. Can you give me a sense of when you approach a new package, a new library, the first time you're looking at it, how do you start to get a sense for the internals and the guts of the project? Because I think for me that's maybe the most intimidating part is sort of where do you start looking to try and solve your problem? Yeah, so I mean, it's very helpful if you have a minimal reproducing example or you have some code that is failing in some way, because one of the good things about open source is that you can just clone the repository and then you have all the code. And you know, if it's an issue you're trying to fix of your own or of someone else's, you have an entry point, which is here's something that here's something that's failing, and then hopefully it has a traceback, and the traceback says where in the code it's failing. So you set a breakpoint right before then. You know, you just modify the source code, make sure that it's in your path, and then you run it, and then it'll stop. And then you just like start exploring. Check out the variables at that time, like what's in scope, what's not. See what the thing is that's failing, what value does it have, maybe what should it have. It doesn't always work, but I've often had the same problem, and generally I've found that the biggest issue is getting an entry point. Like, how do I make it do the same thing? So hopefully, like that's one of the reasons why those issues should have minimal reproducing examples, because otherwise it's really hard to make the code even hit the part where you can start looking at these things in an interactive way.
All right, thanks, Paul, again.